Right, good evening, guys, and welcome to IV Tutor. We are continuing with our revision classes for obviously 2614. So I think last week we looked a lot at dialogues, and we talked about we looked at a few more questions on dialogues. We went on and looked at the big three, and today we want to be looking at inheritance. And we know this is one of the largest topics for this module. One of the core topics actually for this module is inheritance and GUI programming. And we did spend quite a while in our previous classes just looking at this topic and doing a lot of programming. And I think today what I'm going to do is just try and summarize this whole, again, topic, but using an exam question. And if there is one topic where you should make your own notes and make sure that you understand, it's this one. Why? Because there's a lot of concept and a lot happening, and most students struggle here. So if it's going to be an issue for you to remember everything off your head, try and summarize inheritance with maybe 1 or 2 pages maximum, so that you understand how these concepts work and how do you use them, what are the implications of doing what actions in which class at what level. You've got to understand all those things, because this is where the confusion really starts, because most of the things outside of inheritance are very straightforward. But in terms of inheritance, there's a lot going on, and a lot of you guys mix these things up a lot. And if you're given a question, you get stuck really easily. So let's quickly just summarize what inheritance is. And if you can make your notes, let's do that. I'll also try and summarize this for you, but not today. And send you maybe a handout with just a summarized version of the concepts we're going to be discussing starting from today. So let's quickly get straight to this. You're given a UMO class diagram, which is this thing, right? UMO class diagram, like they say here. And I've always said that you guys are lucky because you don't have to draw this in the exam. But if you were going to be able to, if you were writing a sitting exam, you were actually going to maybe spend some time just understanding how to redraw a diagram given a class. But anyway, that doesn't matter. You still have to understand how to interpret a UMO class diagram and understand what it means if something is formatted the way it is. For instance, let's look at the basics here, things we can pick up off the bat. We can see immediately that we've got 3 classes going on here. We've got 3 classes, and this means inheritance, right? This arrow here simply means inheritance. That means savings account is inheriting from account, and so does check account. And that's inheritance. So this one we refer to as the base class. This one we refer to as the sub. So these are your sub classes. And obviously this here is your base class. That's inheritance. And one thing I want you to look at here is you do see that the header of account is in italics. The moment something is in italics, it simply means that it's abstract. So abstract means that it cannot be instantiated, right? Cannot be instantiated, right? But I don't want to say this right now. I will say this again later. But what makes a class abstract is because it contains a pure virtual function, In other words, we can also say that it contains an abstract function, pretty much, right? So a pure virtual function can also be referred to just as an abstract function. So that is what makes a class to be highlighted, to be written in italics. And if you look inside the function, so these are your functions, these are your member variables, right? So we know that if you are looking at a class, it's divided into 2. These are your member variables. And below that, these are your functions, right? And if we look at these functions, right, so a class is always divided into 2 sections, this section and that section, member variables, functions. And sometimes if you look at this one, you don't see it divided into 2 because it doesn't have any member variables, therefore it only has functions. Sometimes they do draw this with another line here, just to show you that we haven't forgotten that it should be divided into 2 sections. But sometimes they just write it like the way it is here, and you know that it's because there are no member variables. But if there are member variables, those will go at the top and your functions will go at the bottom. Now, if we go back to what I'm talking about here, which is your class being abstract, we are saying that if you look inside the class, what makes the class to become abstract is the fact that it does have abstract functions or pure virtual functions. How do you know if a function is pure virtual or at least virtual? There's some slight confusion between differentiating between a pure virtual function and just a virtual function in terms of the functions here. So you know that in most cases, your logic will tell you whether it's pure virtual or just virtual function. But the functions which are in italics here are the ones you should watch out for in terms of trying to identify which one is pure virtual and which one is virtual. A virtual function, we are saying, a pure virtual function, we are saying that it has no implementation in the class, right? So if we look at this class, for instance, a pure virtual function is also given in italics, right? So this means these functions are virtual. So virtual functions will be given in italics. And pure virtual functions, these ones don't have, or it has no implementation in the class. And you also see that it is also in italics. So if we look at this class, we can see that these two functions are in italics, which means they are virtual functions. One of these is pure virtual, and in this case, it's going to be calc interest. And the one that is pure virtual does not have an implementation in the class. And it's because of this function that the class is abstract. So know what causes the other. We don't have an abstract function because the class is abstract. The class is abstract because it contains an abstract function. You don't care when to make a function abstract and when not to make it abstract. That will never be a problem. You will never have to solve for that in this module. They give you the functions. Your job is to identify that this one is virtual, this one is pure virtual. And because I've got a pure virtual function in my class, therefore my class is abstract. Right? That is why it's written in italics. And if you look here, you see settings account is written in normal font, and so does check account, because these are normal classes. So if it's not abstract, we refer to that class as a concrete class. Concrete class means that it can be instantiated. Can be instantiated. That is a concrete class. And abstract class contains a pure virtual function or contains an abstract function and cannot be instantiated. In other words, it contains a function which does not have an implementation. That is what makes a class abstract. So if we look at this class, now if we go and look at the member variables, you've got three protection or access modifiers here. You've got dash, which means private, or a hyphen here means private, and a hash here means protected, right? That is what a hash means. And a plus simply means public, which means it's publicly accessible outside the class. Protected means that it can only be accessed within this class and also within its subclasses. So all functions in savings account or check account can access this variable here if they need to use it. But they cannot access these ones because they are private. So any member variable which is private is only accessible or usable within that class. You can only use that variable if you're implementing a function within that class. And if it's protected, it means even member variables inside your subclasses can also access that member variable. Okay, that is what it means when you say protected. So protected, it means it's protected within that family, but not outside, which means balance can be accessed by savings account and can also be accessed by check account, but cannot be accessed outside of these three classes. So to anyone outside of these three classes, it's private. Doesn't make a difference. Doesn't make a difference. So basically looking at this diagram, that is what we can detect. And these are things that you guys, with enough practice, you must be able to see off the bat. Now, if we focus more on the subclass, you're going to notice that we have calc interest again, which is here. We've got transaction again, which is here. Whenever you look at a function which is repeated inside your subclass, you say that that function has been overridden. So function overriding is when you re-implement a function inside your subclass, which is already in your base class, right? So let me just not make this thing not confusing here. So these are your functions, right? Perfect. So whenever you look at a function which is in the base class and is repeated in the subclass, it simply means that you are overriding that function. And here's one rule that I want you to understand in terms of overriding. Let's talk about overriding a function. If a function is pure virtual inside your base class, in other words, if your function does not have an implementation inside your base class, right? It does not have an implementation inside your base class. That means inside your subclass, you must provide that implementation. So if you think about it, it should sort of sound obvious. Like, okay, we've got this function in the base class. It is no implementation. So if we inherit from this class, what should happen? We should implement that function because it doesn't exist pretty much. It has no implementation. It has been defined by the base class. So the base class has gone and said, look, I have a function which looks like this. How it works is your job. It's your responsibility to actually provide functionality to this function. So in other words, a pure virtual function, in brackets, the one with no implementation, must be overridden by your subclasses. I'm just repeating myself using fancy words. A function with no implementation in the base class must be included in the subclass and then provided with the implementation, right? Which means, same statement, I'm simply saying a pure virtual function must be overridden by the subclass and implemented, right? Let's talk about a virtual function. We'll come back to virtual functions when we have done everything, and then we'll come back to virtual functions. But what I've talked about now is pure virtual functions, where we are saying the moment you've got a pure virtual function inside your base class, that function must be overridden by your subclasses and be provided with an implementation. That is the reason why you see that there's calc interest here and there's calc interest here, because this one is a pure virtual function. Therefore, it must be included. And it's not like they won't give you this function in the subclass in the exam. No. They'll tell you, they'll show you that it's pure virtual. They'll also include this same function here, just like they did here. They won't ask you to go and fix it or include it. It will be there. But you must know that it's there because it must be there. Why am I saying this? Because a virtual function, see, I've changed from a pure virtual to a virtual function. A virtual function does not really need to be in the subclass. These differences are the questions you get as theory questions, where they say, can you give us the differences between a pure virtual function and a virtual function? What are the differences? That is where they give you those questions which say, which one of the 4 following options is not correct? Those questions require you to understand the concept. That is how you can differentiate between wrong and correct answers. So they'll say, it's okay to not include the transaction in savings account. Is that statement correct? I'm going to repeat. It's okay to not include or to not override the transaction in savings account. In other words, if we don't have transaction repeated here, that's fine. Is that true? Is that false? That is where concept comes into play. Do you understand how virtual functions work? Do you understand how pure virtual functions work? I can change the same question and say, is it okay to not have calc interest in savings account? Yes or no? That's a multiple choice question right there. What am I trying to prove to you? Concept is concept. It doesn't matter if the question is multiple choice or not. The concept does not change. So in a sit-in exam, they can say, write the differences between virtual functions and pure virtual functions. In a multiple choice exam, they can simply give you a question that says true or false. What do you think? You cannot guess those things unless you actually know the concept. So the moment a function becomes pure virtual, it must be in the base class. It has to be it must be in the subclass. It has to be in the subclass. It must be overridden by the subclass because it has no implementation in the base. How do you know that it's pure virtual? Because it's there in italics. How do you know that it's pure virtual? Because the class is also in italics. The class is abstract. And the only reason why a class becomes abstract is because it contains at least one pure virtual function. So the moment I see a class that is in italics, I know somewhere in there's going to be a pure virtual function. You look and you find it. So the concept of functions with implementation or no implementation must stick in your mind. That's inheritance for you, right? So what we are doing here is just identifying what's going on with these functions and these classes without implementing not even one function. Right now, we haven't implemented anything. We are looking at the diagram and interpreting what we can tell from what this diagram is telling us. The next thing would be defining these classes. Can you define account? Can you define savings account? And the most tricky questions you get is the ones that ask you to define account. Or they can say which line is the correct definition of the calc interest function in account. Do you know how to declare this class? Do you know how to define this class called account if we have to go and define it? And the tricky part is not defining the class. That you should be able to do in your sleep. How do you define the functions, especially the virtual ones and the pure virtual ones? How do you define that function in your class? So whenever you deal with classes, one of the basic skills, the basic things you must be able to do is to define a class. If you cannot look at a diagram and define the class, you've got to read, you've got to prepare, you've got to work harder, because it's one of the basic things you must be able to do. Look at a class definition, look at a UML class diagram and define the classes, because there is no thinking involved in between. It's direct interpretation of a diagram into a class, which is why you must be able to do it reverse, in the reverse way as well. If I give you a class definition, can you draw the diagram? That's how you know you understand UML class diagrams. So in terms of inheritance as a concept, we haven't said anything yet. We're just describing what's going on with these classes. We know there's inheritance going on. We haven't talked about why was inheritance used in this case. Why are the functions pure virtual? And why is the other one virtual? So in other words, we haven't talked about why. We are simply saying, look, if I look at this diagram, without thinking too much, this is what I can see. And this is what I know by looking at the diagram before you start thinking too much. So this is the first level that you must be at. If I give you a diagram that contains inheritance, can you infer these things? Can you tell what's going on by just looking at the diagram? And the good thing is these diagrams, look at all exam papers, they always look the same. What changes is the context. Here you're dealing with savings account and check account. You can be dealing with payments and types of payments. You can be dealing with books and type of books. You can be dealing with what else, transactions and types of transactions. Doesn't matter. The concept remains the same. There's a base class, there's a subclass. You can override functions. Which ones must be overridden? Which ones may be overridden? When do you make a function virtual or not virtual? Right. So right now, level one, look at a diagram and infer what the class is, what the functions are doing, which ones are being overridden, and the concept behind what you can see right now. Okay, so that's what we can see. Account is abstract. It contains two functions, one that is virtual, one that is pure virtual. Calc interest is pure virtual. Transaction is not pure virtual. How do you know? Don't worry, I know. I'll let you know how you know. But that's what I can see. Okay, And then we've got the usual other functions like get account num, get balance, which are your usual get functions. And there's your constructor. Here are your member variables, account num for the account number, interest rate for the interest rate, type for the type. You go to savings account, it has everything in account plus points. Remember, when you inherit, you extend, which means savings account is an extension of account. So savings account has get account number, get balance, transaction, calc, interest, and points. Even though there's no other extra functions, but you could have more functions in transaction, in savings account than you have in account. Check account is also another extension of account, which means check account has account number, interest rate, type, balance, and overdraft. So whenever you inherit, you extend. Which means, and get this right, and don't forget this, which means when you make an instance of an account, you must give it the account number, the interest rate, the type, and the balance. You cannot make an instance of a check account and not provide the account number, the interest rate, the type, and the overdraft. Because check account is just an extension of account. Which means when you make an instance of a savings account later, we'll get there. But if you are making an instance of a savings account, it needs an account number, it needs an interest rate, it needs a type, and maybe a balance. I don't think balance should be initialized when you start, but anyway, maybe it will always have a default value of 0. But when you start an account, when you make an instance of a savings account or a check account, you still need to provide the account number and the interest rate, even though we don't see them here or here. Okay, because inheriting is extending. So basically, that is the concept of inheritance. You're simply saying, look, 60% of this functionality is common here and there. So why should I rewrite all these things? Let me just extract all these things that are similar and put them in a base class, and only then start extending this base class and have these smaller little other classes which simply extend the common functionality. That is what is happening with inheritance. Right? So level number 1, look at the diagram, look at the class, and just infer what's going on. We don't know yet what function is doing what at this point in time. I know there are functions. I don't know what's get account number, what is get balance, transaction, what is it doing? What about calc interest? How does it calculate the interest? I don't know yet because I haven't read anything. I just know that these are the functions in the classes. This one is the base. This one is the subclass. This one is overriding these functions, because you can see this information on the diagram. So I want your mind to adjust and start seeing things on the diagram that don't require you to think. Things you should just see and understand. Okay, let's go next level. I'm going to go through these questions and explain the different levels involved as you go through the questions. But let's look at the obvious question, at the obvious questions here and obvious answers. What is the meaning of the characters hash and tilde in the member functions account and account list classes respectively, even if you don't go and look? If you're doing inheritance, what does hash mean? It simply means that it's protected. What does tilde mean? That's what you use for a destructor. We've just used this under big 3. So these are basic things that has nothing to do with inheritance, pretty much. Like this has nothing to do with inheritance. It's just used for a destructor. Remember the big 3? Copy constructor, copy assignment operator, and destructor. You always use this with a destructor. Hash, protected. So what does it mean? It means it's protected. What does it mean if it's protected? It means it can only be accessible within the class and its subclasses. Okay, that's protected. Okay, so I'm going to skip 4.2, come back to this one. There are other obvious questions that have nothing to do with inheritance. For example, 4.3. What are the implications of declaring a member function as constant in a class? We have talked about this in a different context. I remember talking about a constant function and the constant keyword. If we, just for the sake of doing this question, talk about constant, we say there are 3 places you will ever see the constant keyword in a class. And let's illustrate. You're going to see this inside the function, outside the function, or behind a member variable. What do you mean? Let's have a class. Here. class, some class. And this class is going to have some member variables and some functions. Maybe this is a constructor of your class, and then you've got a function, get something, and then constant. Constant is outside the function. It could be another function, right? Maybe it's a void function. Do something else, which takes an integer x and constant. Same thing. It's a constant function. It's a function which is constant because constant is outside of the function. And here we could have int some, okay, this thing keeps doing this, int some member variable here. And we could also have another here. Let's do this. Let's have another one here. Constant sum constant equals 15. Sum int constant equals 15. These are all member variables. This one is private, this one is public. But you see this one is constant. Another place you can see the constant keyword is within a function. Int calc something int constant int some input. The other place you see constant is behind an argument within a function, like you see with your big three. How do you do your copy constructor? Some class constant, some class d, isn't it? You've got constant behind an argument or a parameter of your function, right? So these are the three places you ever see the constant keyword in a class. So let's talk about each of these three instances. Case number one, a constant function. A constant function is not allowed to change any of these member variables. Mostly just these will all be under private, end of that. So we could have stuff here, maybe a Q string, another string, and maybe a float, some float here. These are all member variables within our class. If a function is constant, it means it can do anything it wants. It can change any variables it wants to change except for these. In other words, a constant function cannot change the state of the class. Constant function cannot change the state of the class. What do we mean when we say the state of the class? The values of the member variables in the class. Which means it's okay to see inside a constant function other variables being changed, depending on what it's doing, as long as it does not touch these ones. By touch, I mean it does not change their values. It can use them, but cannot change their values. It cannot set any of these. So within a constant function, if we see something like some float equals here, equals 23.3. This is a syntax error because you cannot change a member variable inside a constant function. It cannot change the state of the class, which is these things. So that is the only one thing you're watching out for in a constant function, is it not changing these three. It can change anything else, just not these three. It can change anything else. So it can do something with x, like here it can set x to 20 or do stuff with x, as long as these ones and only these ones are not being touched or changed within that function, you're okay. Second scenario, a constant variable, like in this case, a constant parameter, right? Like in this case. This one simply means that the function can change anything else it wants, even this, but cannot change this argument here within this function. right? In other words, what I'm saying is a constant parameter cannot be changed within that function. That's what I'm saying. If you're writing notes, that's what I'm saying. It can change anything else it wants, but not this. This is being given to the function as a constant. And then we've got a public or a global constant member variable. It simply means that the variable cannot be changed whatsoever, right? A constant variable, whether it's a member variable or not, doesn't matter, but if it's a constant variable, cannot be changed. After initialization, like that. Which means whenever you're dealing with a constant variable, you must declare it and initialize it. You cannot declare a constant variable like this and leave it like that. Doesn't make sense, because then how do we set it? Right? You must always declare and initialize it. After this, cannot be changed. It will always be 12. Right? And why did you write this in caps? As a convention, the convention, and here not a syntax error, the convention is to write it in uppercase. This is a convention, it's a style of writing, it's a way of writing it, to just make it very clear that it's constant. Otherwise, if you write this as, for example, if I come here and I change this to, for example, some constant, it works. It doesn't complain. Why? It's a convention. It's just a way of doing things. Like, oh, you always start your classes with an uppercase letter. That doesn't mean that if you start your class like that, it will complain. No, you can still start your class with a small letter, but usually uppercase, depending on the language that you're using, right? So in this case, it's a convention. There should be a colon here, obviously. So that is everything about constants. These are the three cases you ever deal with a constant and it will not change. So constant function, constant parameter, constant variable. Okay, I hope that is making sense. So let's go back to this question. It says, what are the implications of declaring a member function as constant in a class? It simply means it cannot change the state of the class, or it cannot change the member variables within that class. Okay, let's look at the question 4.4, which says, write the code to implement calc interest, which use get interest rate and calculate the interest charged on a balance amount that is less than 0. So this question has nothing to do with inheritance. It's just a question which wanted you to know how the interest was being calculated in that class. So I'll skip it for now. 4.5, implement the function to string of account list that returns the list of accounts. Here, we are here. Remember I said that, because we are doing this again for the second time, I said that whenever you're dealing with your list class, this is where you loop and you aggregate whatever your function is doing. We'll come back to that one, right? Write the code to implement the destruct of account lists. Again, that one. Write the code to implement the specified constructor of savings account. Note that type of check account is check. So this question is wrong. I think let's just correct it here to check account. Yeah, okay. So now everything says check, or we can change this to savings, but we also have to change that. So let's just change that. Now let's come back to our inheritance. After we look at all of this, and we understand what's going on, we know these are our member variables, these are our functions, these are virtual, pure virtual, these are our subclasses, we are doing overriding here. This is our list, which is a list of accounts, and we achieve this by inheriting from a queue list of account. That is how we achieve a list, right? So we can look at the diagram and we can infer what we need to, right? Let's talk about implementing these classes. Whenever you're dealing with classes, it's a two-step process. Step number one is you define your class. In other words, you say, this is how the class looks like. These are the member variables in the class, and these are the functions, and this is how the functions look, right? And then step number 2 is you then implement every single function in your class. Okay? In the exam, they don't ask you to implement every single function. They only choose the ones that are interesting, right? The ones where there's a bit of concept involved. The obvious ones, nah, they leave those ones out. For instance, you are more likely going to implement functions like calc interest. And let's come here, subclasses. One of the functions you must always be able to implement in a subclass is the constructor. Know how to implement the constructor of your subclass. What does the constructor of the base class do? Usually nothing. It takes account number and assigns it to account number. It takes the interest rate and assigns it to the interest rate. It takes the type and assigns it to the type. And in this case, maybe it sets balance to 0, always, right? So in your constructor, that is where you initialize your member variables. That is the main objective of your constructor. Why? Because remember, whenever you make a variable of type savings account, on that line where you instantiate it, it goes and calls the constructor. So the constructor is used to set the initial state of your class, the initial values of your member variables. Are they going to be default values, or are they going to be provided by the user? What am I talking about? When you talk about instantiating, I'm saying eventually you are making classes because you want to use them. At some point, you're going to make a variable of type savings account, right? Maybe it's called SA. On this line, this is where your compiler calls the constructor of savings account, which means if you want to know how to make a variable or an instance of a savings account, go and look at its constructor. Look at this thing called the constructor, because the constructor will tell you how to declare a variable of type savings account or check account. Look at the constructor. So for instance, if in my main function, I want to make a variable of type or an instance of a savings account, I say savings account, just like you go int X, savings account, SA. Type, name. Type of variable, the name of the variable. Programming 101, right? How do you declare a variable? Declaring a variable is the same as making an instance of, it's just the language which is different, right? So if they say, make an object of type savings account, or make an instance of savings account, or declare savings account, it's the same damn thing, right? It's just a language which is different. But you've been doing this. When you write a program and then say int x equals 5, what have you done? You have made an instance of x. You have created an object of type int. You have declared a variable x of type integer. Same thing. Language, terminology differs, and you should be well acquainted with both. Using object, using instance, right? Or if we add another one, just using the usual term, declare a variable of type savings account. So you start with the type of variable, then the name of the variable. Whenever you make a class, what have you done? You have created a new type, your own type. So how do you make a variable of type savings account? You go savings account, and then the name of the variable. The only special thing about these ones is you must provide what it wants in brackets. How do you know what it wants? You look at the constructor. The constructor tells you that I want a Q string and a double. Because if you see here, the constructor of a savings account takes 2 arguments, a Q string, a N, and a double R. So when you make an instance of a savings account, give it the Q string that it wants, comma, and a double which it wants, maybe 25, whatever. That's how you make an instance of a savings account. And I'm saying, when you do this, this is where it goes and it calls the constructor. You understand? So let's come back here. How do you implement the constructor of a savings account? Just so it makes sense, remember, savings account is an extension of account. So even though you do provide an account number to savings account, it's not in savings account. Where is it? It's in account. Which means for you to fully make an instance of a savings account, you're making an instance of a savings account and account, because these two go together. There's account, which is being extended into a savings account. So if you want to make an instance of a savings account, somewhere in between or somewhere in there, you're also making an instance of an account. So even though you're making an instance of a savings account here, what is happening? You are also instantiating this whole thing here, because savings account is just a mere extension of this thing. So whenever you implement the constructor of a savings account, you must also call the constructor of account, because this thing must exist together. These two must exist together as one instance. So you cannot just implement the constructor of savings account and you ignore the constructor of account. So basically, be able to implement the constructor of a base class. And it's not complicated. It doesn't change. I've explained it before. I'm explaining it now. Whenever you implement the constructor of a subclass, you must call the constructor of a base class. The syntax goes like this. You go, I'm implementing my constructor of savings account. Let's do it. So here's the implementation. Savings account, ... savings account. Remember, when you're implementing a function, you start with the name of the class, double colon, then the function, right? So this is how you would have implemented it. So it takes a Q string, account name, and a double interest rate. As it is, I haven't done anything. That is what is on the diagram. It's here. There it is. Q string AN double IR. Remember, when dealing with a UML class diagram, it's written in reverse. You start with the name of the variable, then the type, like you see here. Account number is a Q string, interest rate is a double. But when you write the code, you start with the type, then the name of the variable. Okay? So let's look at how you would implement the constructor of a subclass. Here it is. So what are you trying to achieve in a constructor? Remember, in a constructor, all you do is you initialize your variables. So you look at savings account, what does it have? Savings account does have points, right? It would have made sense if we had some points here. There's a missing, I think there was a missing argument here. There's a mistake here somehow. I'm pretty sure of that, but anyway, it doesn't matter. So let's say you've got an account name and an interest rate, right? Your account name obviously should end up, your account number should end up here. Your interest rate should end up here. And let's say we default our points to 0, right, in this case, because your constructor is going to initialize all your member variables. But in savings account, we only have one variable, which is your points. So we can say inside savings account, we're going to initialize points to 0. So you start off with points equals 0. So maybe there's no mistake, it's right. It always starts from 0. But guess what? Do you see that you haven't used account number and interest rate? Anyway, that is where I say when you implement the constructor of a subclass, you call the constructor of the base. You call the constructor of account. Look at the constructor of account. What does it need? It needs 3 things. Number 1, it needs the account number, the Q string. It needs a double, the interest rate. It needs a type. And guess what? You've got these 2. Because the constructor of savings account is being given the account number and the interest rate. So you've got these values here. Just use these 2 values to call this constructor. What you don't have is the 3rd one, which is the type. But you know what the type is. It's savings account, right? So in this case, we are saying that, oh, I'm doing savings account instead of check account. Doesn't matter, same concept. So what you're doing is you're saying, okay, how do you call the constructor of the base class? You do this. After your closing bracket, you put a colon. Then you call, please, I repeat, you are calling it. So don't you do this account, then you go Q string. Whenever you ever call a function, then you repeat the Q string. You're not defining the function, you're calling it. When you call a function, you supply the arguments like we're doing here. Remember, we are calling the constructor, we are calling it. We simply provide the values. You don't call a function and then you define, and like then you call Q string thing inside the function when you're calling it. No. When you call a function, you supply the arguments, the things that it wants. So you call the constructor of the base class from the subclass. How do you call it? After your closing bracket, you put a colon, then you call the constructor of account by simply going account, open bracket, then you give it what it wants. What does it want? It wants the account number and the interest rate and the type. 3 things it wants. Where do you get the account number from? You have it. It's being passed in as AN. So just call it and give it AN, the account number. Interest rate, again, you've got it. It's being passed in here. Just take this double here, this IR here, and pass it to the base class. Call, use this one to call. What else does it want? It wants the type. Well, we don't have it. Yeah, we don't, but we know this is savings account. So we can just put the type here, savings account, or just savings. They will tell you what to put here. Like here they did, right? They said, if it's a check account, just use check for the name, for the type. They were going to go, if it's savings, just use savings for the type. So you would have it. So that is what you do. You put the type here. So what I've done is I have called the constructor of my base class, which is account, by giving it the 3 arguments that it needs: the account number, the interest rate, and the type. And what else have I done? I have initialized my points to 0. Another syntax is this, which is the most common one, actually. Your member variables, you may choose not to initialize them inside the constructor. You can still do it here if you want. You go points, which is your member variable. I'm initializing it, open bracket, to 0. It's like you're calling a function. It's just the syntax, and you just don't do it there. These 2 do exactly the same thing. It's just a syntax flavor. You choose what works for you, but this one is the most common one you would see most likely in code, if it's written by your lecturers. They prefer this. Okay, so that is how you call the constructor of a subclass. That is how you implement the constructor of a subclass. You define it as it is, you do your arguments as they are, then you just call your base class constructor and supply every single argument which your base class constructor needs. You will have some of them. The ones you don't have, you supply the value. Like in this case, it wants the type, we don't have it, or we know, we supply the value, it's savings. So you can do the same for check account. That is how you implement the constructor of a subclass. So whenever you look at inheritance, you must be very comfortable implementing the constructor of your subclass. Any one of these 2. They will never ask you to implement both. Just one. One is enough. And given, again, and this is why I'm saying, even if it's multiple choice questions, they can give you 4 different implementations and they say, choose one, which is correct. You only choose if you know. There's no choosing if you don't, or eventually you end up choosing, but you have to know these things. Even if you're not writing the code, if you're given 4 different variations here, would you know which one is correct? To know which one is correct, it means you know how you would have written it if you were doing it, isn't it? So concept is important because that is how you pass. Okay. So I went straight to the last question because it's very close to what I was explaining. And now we are talking about implementing your functions inside your class. Let's look at, let's go back here and let's go back and look at our subclass here. We've got 2 functions here, transaction and calc interest. You cannot look at these functions and immediately you know how to implement them. Someone has to explain to you how to implement this function. Otherwise, without some sort of description of what the function does, there's no way you can implement it because I don't know how to calculate the interest. What is it doing? Same applies to transaction. You don't know what transaction is doing unless something says this is how transaction works. So if we go to these questions, we have done, let me just keep track here. We've talked about 4.1, right? We've talked about the constant keyword. No, we haven't done this one. We've talked about the constant keyword. We've talked about how to implement a subclass instance. Now let's go back to 4.2 because this is also still inheritance. Write the code no implementation. In other words, what are we doing? We are defining, which is why I said you must be able to define a class. Defining a class, you look at the diagram, you define. There's no thinking in between because you look, define. It's a direct interpretation of your class, right? Look at the class, define it. In this case, they are not saying define the whole class. No, they are simply saying write the code to define all member functions of account as shown in the diagram, including the definition of the destructor and the toString function. Let's understand the question here. Define all the functions as you see them in the diagram, plus, including, why is there a plus? Because these ones are not in the diagram, but they still want you to add them to your definition. What is the function definition? A function definition is where, if we are writing a class, this is the definition. This is what they're talking about. Just show us this part. Function definitions, nothing else. Don't write the class, just define the functions. This is the part they are asking for. Show us the functions, how you would define them. An alternative version of this question is where they say define the class, period. So you define the whole class, you put all the functions and all the member variables. In this case, they are saying just define the functions, ignore everything else, which means they are saying we are interested in this part and only that one part. How would you define your functions? There are easy functions to do. Functions that you just do as they are. So if we look at this, for example, let's look at our constructor account. It takes a QString called AN, a double code IR, and a QString code TY. You don't think, you just define, which means if you are defining this inside your class, how would you do it? Let's do it maybe here. Let's do it here. Ignoring the class, under public, you're simply going account. It takes a QString code AN, a double code IR, and what else? QString and a QString code TY. That's how you define it. Next function. I'm not thinking that's what it looks like. It's there. You can look at it and write it. Let me go back here. Next. Which one is next? Get account num. It's a function, returns a QString, right? You can see it's there. Okay, so what you do, you just write it as it is. You just go here, get account num. It returns a QString. I can't see here. Okay, returns a QString. It's called get account num. Done. Next function. That's how you do it. You just look at the function and you write it down. Let's look at the next function. Get balance. Right? So if you're confused, I haven't seen any question, but I'm just saying it anyway. It's get balance, open close bracket, colon, double. That's what it looks like. You don't see the colon here because it's, the quality here is a bit poor, but there are colons here that you're not seeing. They will be very clear in the exam, don't worry. So it means this is your function. The arguments will go inside the brackets. After the bracket, colon, return type. If there's nothing here, it means it's a void function. Like you see calc interest. There's nothing after the closing bracket, which means it's a void function. But get balance returns a double. So I can go here and just call get balance. As it is. No, not that one. Here. Okay. So I can go double get balance. Next function. So that's how you do your functions. The only tricky functions in this case were the virtual function, transaction, and calc interest. Transaction takes a double code AMT and it's virtual. It's void because there's nothing under the closing bracket. You see that? There's nothing here. If it was returning something, we would have seen something like this, colon, return type. But if there's nothing afterwards, it means it's a void function. But in the brackets, it takes a double AMT, transaction, but it's a virtual function. So if it's a virtual function, easy. All you do is you just put the keyword virtual. That's all you do. Just put it at the beginning. So you go virtual void transaction, which takes a double AMT. Done. And calc interest, same thing. Virtual void calc interest. But this one is a pure virtual, so what you then do is you simply go equals 0. That's how you do a pure virtual function. It doesn't matter if it returns a Q string or it doesn't, you just go equals 0, always, and you put that. So it's virtual, and at the end, equals 0. That's how you define a pure virtual function. Cool, let's stop here for now. We are going to talk about the other two functions. I think we've got a destructor here. We also need to put our destructor, which is account, and we also need to put our QString function here, virtual QString to string. But we'll talk about this in our next class, this last function. Why is it virtual? Why did you make it virtual? Yeah, we'll talk about it. But for now, I think let's just stop here with that one. And in our next class, we are continuing with inheritance. We are going to talk about why, if we are going to add a function called to string inside this class, what are we watching out for? When and why do we need to make a function virtual? Why is this virtual keyword there? What does it do? And why and when do you need to worry about a function being virtual inside your base class? So this is always going to be in the base class. You don't worry about your function being virtual inside your subclass or anywhere else. It's only about the base class. When and why do you make a function virtual inside the base class? That we'll discuss in our next class. Otherwise, we'll continue with inheritance, and I hope this is making sense. Make some notes, understand all these concepts, because it's very crucial for you to actually do understand these concepts. If there's anything that's not making sense, please let's shout. Let's ask the questions and let's help each other. All right, due for the next class. Otherwise, I think there aren't a lot of questions here, if any at all. I think, yeah, we'll get there. At some point, it's either you ask or I'll ask. One of us has to ask the other. So we'll get there. But for now, let me just do a quick recap of the whole inheritance topic. Let's recap on everything we've covered so far, and let's look at as many questions as we can under inheritance. But go and look at those past exam papers. Look at those questions. If there's a question that is not making sense, let's bring those questions, let's discuss them, and let's see that, oh, it's the same concept being recycled across different classes and different years. Otherwise, the concept hasn't changed yet, and will not. So we'll keep practicing, we'll keep doing more questions until you guys understand fully what's involved in inheritance. But in the meantime, we'll stop here. Have a good night and stay safe.